Hey everyone, so we're just going to quickly recap a little bit about periodic trends and why they exist or how they occur. So, just a quick review to hit the high points of this Coulombic attraction concept. The main thing that we want to take away is how, first, how the distance affects the attraction. So, for this question right here, number 2, as the distance increases, our force of attraction is actually going to decrease. So, as those electrons get further and further away from the proton, which we can think of as kind of like a magnet, then it's going to, that attraction between them is going to decrease. So, if we think about on the periodic table, as we go down that column, we get more and more energy levels, right? Because our electrons are increasing. And so our valence electrons are basically staying the same, but the distance between those valence electrons and the nucleus are increasing. So this relates to that concept that we just said, that as the distance between those two particles increase, that our attractive force is going to decrease. Okay, so the next concept was looking at if we change the number of protons. So instead of changing distance, we're now going to look at changing those numbers of protons. So if we notice here in this picture, as our protons increase, right, that means that our force of attraction is going to increase as well. So you can think of it kind of like a large magnet in the center of the atom, and as we're kind of increasing the strength of that magnet, they're going to be able to attract those electrons a lot better. So if we compare elements in a column, so sorry, this is not column, this is definitely row. In a row, then we're going to notice that those the distance stays the same. So all of these elements are on the third row. So all of their energy levels are the same. They all have 3 energy levels. So the distance isn't changing, but we're actually increasing the number of protons. So as we go across the periodic table, the distance is going to stay the same, but the number of protons is going to increase. And when we increase those protons, we also increase the attractive force. Okay, so I'm going to skip down a couple of slides here, and I want you to take your green sheet that you got, and we're just going to take a second and fill in these blanks. This is going to help us when we get to our trends and we start trying to compare things in columns versus comparing elements that are in rows. So if I'm in a row, okay, so we're going to talk about a row first. Remember, our number of protons is increasing. So we're going to write increasing in this blank here. And that's going to lead to a stronger attraction, right? If I'm talking about a column, then my number of energy levels is increasing. And that's actually going to mean a decrease or a weak force of attraction. Okay, so if we're comparing in a row, we're always going to compare protons. And if we're comparing in a column, we're only going to compare energy levels. Okay, so we're going to use our green sheet to try to help us answer a couple of questions or kind of jot down a few notes here. So when we talk about the size of the atom, you can kind of check yourself with the notes that you took yesterday. Make sure that you have the trends written down correctly. Make sure you have the definitions written down correctly, because you want to be able to explain this on the test. So we have our distance. When we think of radius, we're really just thinking about half of a diameter, right? Half of a circle. And so when we say the atomic radius, we're really just talking about essentially the distance between two atoms. So you can sometimes think about it as the size. That's usually how we refer to it, because we can't really measure the size of an atom because it's hard to measure that electron cloud, but we can measure essentially the distance between two nuclei. And we know that the bigger the atom, the further apart those nuclei are going to be, right? The more space they're going to take up. So if we think about our trend from left to right, so as we're going across the table here, we know that our size is going to decrease. Okay, so I'm just going to put a little arrow down. And then if we're going down a group, we remember from yesterday, that means that our size is actually going to increase. So let's talk about why that is. When we're going across a period, right? Remember, what is changing? So look at your green sheet. What does it say we're going to compare when we're talking about moving across? We're going to talk about our protons. So our protons are increasing, which means a stronger, I'm going to just put F of A, force of attraction. So we're literally pulling those electrons in closer to the nucleus. That's what makes it smaller. When we're looking down a group, our size is increasing because we're really getting more energy levels. So our energy levels are increased, right? When we're looking down a group, we're only going to talk about energy levels, not protons. So as we get more energy levels, they're getting further and further away. That atom is getting larger and larger. Okay, electronegativity is essentially the ability to attract electrons, specifically when we're talking about a bonded compound. Okay, so when something is bonded together, how well is it going to be able to attract those electrons, or essentially how strong of a bond can it make? So if we think about our trend as we're going from left to right across a period, this is going to increase. Okay, so as we're going from left to right, it's going to increase. And again, why does that happen? Our green card is going to tell us when we're looking, when we're comparing things across, we're going to talk about our protons. Right, so if our protons are increasing, that means that our force of attraction is also increasing. So it has a better ability to pull in electrons or attract electrons. Okay, so everything is going to come back to this force of attraction that we're talking about. When we're going down a group, we're going to see that decrease. Okay, so let's think about why. If we're comparing in a down a group, that means we're going to be comparing energy levels. So our energy levels are increasing, right? Which means that our force of attraction is actually decreasing. Those electrons are getting further and further away, so it's going to be hard for us to attract any electrons because it's so far away from our nucleus. Ionization energy. This is very similar to electronegativity, but it's really just the opposite. So it's saying that instead of the atom itself attracting electrons, so instead of essentially trying to pull other electrons towards it, we're talking about removing an electron. So can another atom take our electron? Okay. So we're going to think about our trend as we go from left to right across. This is going to increase. Okay, so it's increasing from left to right. Why is that? Well, let's think about it. We have to compare our protons because we're talking about across a table, right? Our protons are increasing, which means our force of attraction is increasing. So it's going to be harder, more difficult for a different atom. Okay, that's kind of the key word here. Okay, a different atom to take, I'm going to just put a little E with a minus sign, our electron. Okay, so again, it's not about us taking electron, it's about somebody else taking our electron. If I have a really strong force of attraction, that other atom's going to really have to pull hard in order to take my electron. When we go down a group, I'm going to swap my color so it doesn't get confusing. Down a group, then we're going to see a decrease. Okay, so why is that? Well, if we're talking about down a group, right, down, then that means we want to compare energy levels. So our energy level is increasing. We have more energy levels, which means that our force of attraction is going to decrease. Okay, so the more energy levels I have, the further away those electrons are, it's going to be easy for someone to grab it, right? Kind of think about it. If you have snacks and they're real close to you in your lap and you're holding on to them tight, somebody's got to really pull hard to take away your snacks. But if you've got them sitting across the room, right, it's real easy for somebody else to come and take those snacks from you. So that's kind of the same idea as ionization energy. So we've got these, our green sheet filled out. So we're going to just do a couple of questions, and I'm going to kind of walk you through 2 of them, and I'm going to let you try a couple and just kind of see how we're feeling. So for this practice question, we're really just talking about the radius, and I want to compare aluminum and sulfur. So let's find them first. Here's aluminum, here is sulfur. So I'm comparing 2 things in a period. Okay, a period is just another word for row. And then a group is just another word for column. So we're talking about a period, so I can ignore this whole group section, right? And it's telling me, right, we want to compare protons, right? Don't forget to look at your green sheet. So let's see if we can fill this in. So we know we want to compare protons. So aluminum has 13 protons, right? And I know that because of that atomic number. Sulfur has 16 protons. So which one has the strongest force of attraction, right? Sulfur has the strongest force of attraction. Again, I'm just going to say force of F of A, force of attraction, right? Because it has the most protons. Okay, so what does that mean? That means it's going to be pulling in. It can pull the electrons closer. Okay, so that means that sulfur is going to have a smaller radius than aluminum. Okay, so this whole little segment right here, this is what we call the reasoning. Okay, this is kind of more of like your explanation. Notice I have a couple of things. I'm talking about my force of attraction, right? And I'm talking about how that force of attraction actually affects the size. So when you do your practice questions, you want to make sure that you're trying to explain that as much as you can. So use your green sheet to help you. Okay, so just as a little tip, your 2 practice questions are going to be the highest ionization energy. Okay, so first step is we want to just find them. So we're talking about sodium and potassium, right? So these are elements that are in a column. So make sure you use your green sheet to help you answer these because they're talking about a column. This question is comparing phosphorus and chlorine, right? And these 2 elements are in a row. So you want to make sure you're using your green sheet to help you correctly answer or compare elements when we're that are in the same row. Okay, so I'm going to let you try these 2, and then we'll go over this again throughout the week.